I will do that. Let me double check. It's working real fast.
Yeah. And make sure from your view, you do gallery view, right? So that shows up on the side. Perfect. Yeah, thanks everybody. Yeah, I'm super excited to see you all. It's always great to see everybody. Okay. All righty. Good morning, good afternoon, good evening, wherever you're joining us from. Very excited to have you join us for our first SAI Symposium. I can't believe I'm saying that. It's been a long time in the making, and it's something that I've been looking forward to, and I'm glad that we managed to make it work. My name is Faniel Windy. I'm the Chief Resident and founder of SAI, the STEM Advocacy Institute. This afternoon, we are going to be exploring some of the work that goes on at SAI. And then before I tell you a little bit more about that, what is SAI? So SAI is an incubator. It provides support to accelerate the building of new tools and programs to strengthen the networks of access between science and society. Really, at the core, we focus a lot on that connection between science and society. What we try and do is provide that infrastructure, the funding, the training, and the mentorship to these practitioners and researchers that are working at the interface of those two fields. And it's been really exciting to get to work with some really amazing people over the years. And this past year in particular, we just wrapped it up June 30th, was phenomenal. Working with interns, fellows, and residents that have just joined us as well. And also lots of new staff that have joined the wagon who are just as passionate about exploring this connection. And so it's been a year of rapid growth. We're still growing, lots of work to do. We have a new library that we just set up as well. Do check that out, SCI Library. A lot of reading material. In fact, our keynote speaker today, we have made sure to include some of his work in there as well. Huge thanks to Claire for all her social media that has just skyrocketed, and we are out there now definitely telling our story. So Claire, thanks to that. Huge thanks as well to Bree with us today. So our event specialist who has also made this, I want to say this event in particular possible, because we were struggling along and she came and put us on the right track to make sure we can execute this. We're going to be releasing our formal annual report very soon. So keep an eye out for that. But this is a quick snapshot of all the work that we've been doing. People are working some really great projects. Please visit our website too. And this is just a small snippet of the projects people are working on, residents and our fellows as well. But do go online and read up on them, click on them and then review. Huge thanks to our funders and sponsors who have made this possible. And we are always looking for new funding and new opportunities. So if you know of people that we should be applying to, let me know. And we're always looking to provide more support for our residents and fellows. So yeah, this is a quick snapshot of our support structure. And so today, what really brought us here was really an opportunity for us to explore this interface of science and society, the research and practice insights. We have these people, these two groups of people that are at the interface. And there's a huge overlap in terms of what they do. And so we felt it was important to bring them together and be able to see their perspective, a summary of their work, right? And hear the stories right at the edge, right, of what they're working on. And today we have assembled here a group of people that I'm really excited to hear more from, both from our junior residents, Rosario and Priscilla, and also our senior residents, Pete and Adriana, who will tell us more about their work. And capping us off towards the end, Dr. Bruce Lewenstein will give us a summary of sort of where we've been, where we are, and where we're going. And so he'll be appropriately taking a seat back at the early stages, taking back and looking at what we're all doing and giving us to tie this all up together towards the end. So I'm really excited to have all of you here with us. So this is how it's going to work. We're going to divide the session into two. We're going to have the practitioners, as we lump them here, Rosario and Priscilla, go first. They'll each have 10 minutes to give their presentations, followed by 5 minutes of Q&A. All right. And then after that, there'll be a chance for all of you to also visit them individually and network with them and ask them further questions in the breakout rooms. There'll be 2 breakout rooms labeled with each their name, so you can jump in there and talk to them for about 5 to 10 minutes. Then we'll repeat again, second group. Pete and Adriana will go ahead, same thing, 10 minutes, 5 minutes Q&A, followed by that one-on-one breakout session that you can join. And the people in the Zoom can actually jump between the Zoom rooms as they wish. For those of you who are watching online, please drop your question in the chat, and we will make sure to get those questions out during the Q&A. At the end, please do stay towards the end. After the keynote, we're going to have a special link to go to our platform called GatherTown, which will allow all of us people here in the Zoom to jump in and be able to network broadly. So think of it as one giant Zoom room, breakout room, Zoom breakout room. So you can have an avatar and you can explore, bump into people, say hello, kind of trying to mimic that conference style random meetings that you can make. So with that, hopefully my remarks were brief and we still have time. I would like to welcome to the floor first Rosario. And quick story here about Rosario. She's a student, PhD student at Illinois State University, and was our C4, cohort 4 fellow. And I'm really excited to hear updates to a project that she's working on called Pub Navigator. And her title is called Pub Navigator, Addressing Barriers to Science Literacy. Rosario, welcome.
Thank you. All right, thank you so much for the introduction. I appreciate it. Again, my name is Rosario Marroquín-Flores. I am a 5th-year PhD candidate at Illinois State University and a junior resident here at SAI. And I'm excited to talk to you guys about my project, Pub Navigator, and how I'm using it to address barriers to science literacy. So scientists primarily communicate their research findings by publishing papers, and we've become more and more productive over time. So while we're putting out more and more papers, they're also becoming increasingly complex. Due to levels of specialization, there's a lot of field-specific jargon that makes these really difficult to understand. At the same time, I'm sure many of you are familiar with this, a lot of these papers exist behind a paywall. So you are either affiliated with an academic institution that subscribes to these journals and gives you access to these papers, or you have to pay for them. Additionally, most people are learning about science by following mass media outlets, but less than 1% of our papers are showing up here. So this is problematic because it means that scientific literature is just not accessible to general audiences. It's not being covered in the news, it's behind a paywall, or even if you do get access to the article or to the journal, it's filled with so much complex language that it becomes difficult to understand. And as a result, science literacy is not keeping pace with scientific output. And this is what kind of brings me to Pub Navigator. Pub Navigator is a science communication platform that shares the findings of published papers using accessible language. We take peer-reviewed published papers and convert those papers into articles written at or below a 12th grade reading level. So each of these articles includes a biographical portion to talk about the author, a brief description of the research field, an overview of the paper, and then a deep dive into 1 or 2 figures or research methods, and then a big picture statement so that the reader gets to know why this research is important and how it might apply to their lives, and a decoding the language section where we describe and contextualize any complex terms that we use in the article. And our mission with this is to improve science literacy by making scientific research more accessible. So how it works is the primary author on a paper will fill out a template on the Pub Navigator website. Once we receive that template, we give it to an editing team. The primary author tends to really struggle to convert their paper into something more accessible, and that's the job of our editing team. That's what they're there for. So they will make sure that the article accurately reflects the information from the published paper, and we'll make sure that it's easier to read. So we make sure that every article is written at or below a 12th grade reading level. And we do this using this tool. This is called Story Tools. It's an online program that will take a passage and then grade it for its level of readability. It uses these 7 different readability indices, and we'll give the passage a grade. So one index might look at the length of a sentence, one might look at the number of words or the complexity of the sentence, one might look at the language used in that sentence, and then it produces a composite score or an average grade level. And so we take that average grade level and make sure that every single paragraph in a Pub Navigator article is written at or below a grade of 12. And we found that this has been pretty effective. The Pub Navigator articles are easier to read than the published papers. This is an example of one of those readability indices. And so in this case, a high score means that it's easier to read. And as you can see, our articles are consistently higher than the published papers, indicating that they are easier to read. So Pub Navigator launched in December of 2020, and I'm excited to announce we've made some really good progress. We've released 18 articles. And when I first started this project, I was primarily working with graduate students in my department. So we had graduate students volunteering as editors and graduate students submitting their research. But since the launch, I've been able to recruit 8 external volunteers and 4 external contributors. I've had over 1,300 visitors to the site, over 4,400 views, and have people tuning in from 44 countries around the world. So I'm really excited about the progress we've made so far, and I'm hoping that we continue in this direction. So when I first started this, my target audience was really just the general public. Anyone who wants access to this information should have access to it, and that was really my goal. But as I started to talk to people and work through this, I found another potential target audience, and that's students. So Pub Navigator articles have the potential to be used as a teaching tool in the classroom. And so I've also been exploring this further. I've been working with a faculty member at my campus, Dr. Rebecca Darner, and we've been exploring the capacity of these articles to be used in the classroom. To do this, we've integrated 3 of these Pub Navigator articles into a freshman level biology course for biology majors. Students read these articles and then discussed these articles in an online asynchronous forum. We then collected student responses and then looked for evidence of deep versus surface learning. So these are some of our very preliminary results from one assignment. But what we're finding is that most students who are reading these articles are engaging in deep learning practices. So this is a visualization of our data. This blue indicates deep learning and this orange indicates surface learning. Each of these subdivisions in the circles shows a different type. So what we're seeing is that most of the students who are engaging with these articles are engaging in deep learning practices in many different types. So this is all really preliminary, but it's really exciting. So this gives us some evidence, at least, that these articles might be useful in the classroom. So hopefully, as I continue to go through student responses, I'll find more evidence of this. At the same time, we've also gotten some other really great feedback from the students reading these articles. And that feedback is based on the format of the articles themselves. So I'd like to read you a couple quotes. This student said, "While I read this research study, one thing I enjoyed was the introductory page that gave the reader information about the researcher. I felt like I knew the researcher a little bit and became all the more interested in her study." So this is great feedback. To me, this suggests that this reader really liked that biographical portion of the article. It helped the reader to connect with the research and the science. So this is great feedback. Another student said, "I also liked that this study had nice figures and a glossary at the end, in case you needed clarification on any terms." So to me, this suggests that this reader really liked that decoding the language section, that the words there help the reader to understand the content of the article. So it's also really great feedback. So I'm hoping that as I continue to go through these student responses, I continue to get this type of information, and this should allow me to improve the format of the articles to make them more effective. So my vision with this is to make scientists more approachable, increase science appreciation, and promote science identity. So when we give these articles to students in the classroom, people who might not yet identify as scientists, I'm excited to be getting the type of feedback I'm getting, because it suggests for at least some of these students, these articles are helping to make scientists more approachable and to make these science more interesting. So I'm really excited about this. I'm hoping to get more information like this moving forward. And for my next steps, I think it's going to be really important to establish a funding structure. As I said, we really operate primarily with volunteers, and I have some really awesome, really consistent volunteers, and I love them, and they deserve to be paid for their work. So I think moving forward, I need to focus on applying for grant funding to make sure that we're appropriately compensating our editors for all their hard work. I think it's also going to be important to recruit writers. These articles can take anywhere from 6 weeks, even 10 weeks to publish on the site. And that all depends on how complex they are when we get them and how people meet their deadlines. And I think one way to speed this up would be to write the articles ourselves. So perhaps the contributor will fill out the biographical portion and then we write the article. And that might help to speed up the process. And as I said, we're getting viewers from all over the world. So at this point, I think it makes sense to start translating some of these articles into other languages to increase their level of accessibility. So if people in the community or maybe partners with SAI might be interested in collaborating with me on this, I'd love to bring you in to help get these articles into other languages. As I said, Pub Navigator is a website, so it's important to learn how people are engaging with the website. What pages are they going to? What are they clicking on? But in order to get that type of data, I need to upgrade my platform. So that's something I'm going to do moving forward. And then finally, we're getting some really interesting feedback in the research. So I'm going to continue to pursue this and see what else we can learn and how we can continue to improve this program. And with that, thank you so much for listening. If you're interested in volunteering or in contributing or just learning more about Pub Navigator, please visit pubnavigator.com or go to the QR code here in the corner. And with that, I'm happy to take any questions that you have for me. Thank you.
Wonderful. Thank you, Rosario, for that update. Amazing just to see the growth over since you're a fellow now to this just rapid growth. Questions, you can please raise your hand so that I can pick on you and give you space. You're getting a lot of claps, Rosario, just so you notice. Questions, everybody. We have a little bit of time. See, Jonathan Risco saying that was fantastic. Claire, then great work for people. Okay, so Jonathan, all right, let's see. Go ahead, Jonathan. So hopefully you can, Bree, can you give him a chance to unmute?
There we go. Now can you hear me?
Yes.
Fantastic. Rosario, that was excellent work. Excellent work. One of the things that, some questions and some comments that I had. The first is that there was a video publication outlet. I don't know if they're even still active, but they were contacting scientists a long time ago and asking them if they would be willing to showcase their work on video. And I think what you've done, combined with some sort of video comments from the authors that you're contacting the author, would be very powerful. Of course, you have to, since you're involving the author anyway, you have to watch out for copyright, but having them involved in the process, at least by creating a video, might be really valuable. And a lot of people engage with video, and you could translate that very easily to social media as you advertise your website. The other thing that I noticed that you were doing is you're essentially taking the model of UpToDate, which is a medical science, a medical sciences summary of papers that many students use at the professional level. And you've done this for singular articles. I like the fact that you're bringing the reading level all the way down to 12th grade or lower to open that up to students who are much younger. So you might want to also think about, as you increase the number of articles and the number of contributions that you get, to summarize groups of literature and not just singular papers. And you might even, if you do decide to go the route of video, having these authors come together in video forums on this website. I think people are going to find a lot of value with that. Anyway, I just want to leave you those comments, and I suppose my question to you is, how do you see your project growing from here? Like, what's your next step? You mentioned a lot of things that you could do, but what's the most valuable thing that you can do right now? Thanks.
Thank you. That was really great feedback. That's definitely something to look into. I think moving forward, the most important thing is going to be to continue to expand the number of articles that we have. So right now we're really biology heavy because of just where I am. So it'd be really good to make sure we're covering other research fields and really bringing in new contributors. So getting these articles out faster, I think, is going to be the most important part, because in the future, I see in my head having this database of all of these different articles, so that if you're a teacher or if you're interested in a particular subject, you can just look it up and here are all the articles that are related to that subject, and then you can just download them. And that's something you can do on the site too, is you can download any of the articles. So that's where I'm thinking, but I really appreciate the feedback. Thank you.
Yeah, those are Bruce just put in a link there. So the journal Visualize Experiments is what Jonathan's also referring to. I think add on to that is your collaboration with existing journals, right? And talking to them and figuring out, hey, can we collaborate somehow? And having a link, right, for authors who publish to come to you, right, to do this sort of translation decoding, as you eloquently put it. Jessica. Go ahead.
I think I'm unmuted now. Rosario, that was amazing. Congratulations on all this work. It's really awesome to see how much you've done in a short period of time. I have 3 questions for you. So one is, I guess, a question about scalability and how you are thinking about scaling up to having like more people help with some of these articles. The second question is language accessibility and like thinking about beyond English, like other languages that potentially could be translated into. And then the third is just like collaborating with schools. Like, have you thought about sort of integrating into like a K through 12 education system and like what that would look like for a specific curriculum, or just sort of leaving it up to teachers to use this as a resource? I'm not sure what the right answer is, but I'm just curious what you think.
Yeah, thank you. So for your first question for scalability, I think that that's kind of where funding comes in. So I think that as long as we're operating on a volunteer basis, you know, I love our volunteers and they can put in as much time as they can, but until we actually have funding, I think that that's going to be a limitation. So I think writing the articles and paying our volunteers is going to be really important to scaling up. So that's why I kind of want to focus on that. In terms of languages, I think it makes sense to select languages that are consistent with the places our viewers are coming from. So right now we're primarily the United States and Canada. So I think it makes sense then to go straight for Spanish, as you know, that seems just pretty straightforward. If I were to choose a second language, I think in that case, probably French or something. But I think it's really just going to depend on who all is tuning in. So moving forward, I think Spanish is going to be what I'm shooting for. So to your final question about the classroom, I haven't really thought about reaching out to teachers specifically. So that's really something to keep in mind. Another thing to think about. So one reason why I went for undergraduate classrooms when I was doing this study is because a 12th grade reading level is still actually pretty high. So for if you're reading a news article, everything is written around like, I think it's like a 6th or 8th grade reading level, something like that. So we're still pretty high up there. So I think that this is something that either maybe a senior, junior level might be fine if they're already in a science class. So I haven't really considered reaching directly out to high school classrooms. But for undergraduate classrooms, I almost feel like it's a seamless entry. You just give it to the students. So I have been reaching out to faculty to see if they could pick papers that are, relevant to their curriculum. Hopefully that answers your question. Thank you.
That's great. That was sorry, I think Pete, a couple of questions I read here. Comments, Pete, creating template lesson plans that I could utilize your articles. I think that would be a good idea. Bruce mentioned that he's working with some undergrads at Cornell on something called Poli-Sci, which is really cool. Glad to connect you with them. And so what this tells me is, I think there's a lot of potential collaboration, right, that you can explore. And that's the beauty of all this. I think we're all trying to tackle this problem from multiple angles and finding ways to coordinate and collaborate is critical. That's why we have these breakout session and the session at the end to encourage these kind of exchanges. Rosario, that was fantastic. Thank you so much. Stick around because you're gonna, so other folks can jump in and ask you further questions and engage with you on potential collaboration. Okay, so next up is Priscila Guzman. So she's one of our junior residents and her title is STEM Latinx and the Importance of Community Ties. She's also a former C4 fellow, and she's currently a PhD candidate in the Division of Biology at Kansas State University. Priscila, welcome.
Thank you, Fanuel, for that introduction. As Fanuel mentioned, my name is Priscila Guzman. I am a fifth-year PhD student at Kansas State, and today I'm going to talk about my project, STEM Latinx. If I were to ask you all, like, what was your first influence of, or what inspired you to become a scientist, chances are most of you would have like something in mind, like someone in mind, or like a TV show or something like that. And that like shows the importance of just role models, or in this case, like, or of a figure, in that you can follow, like you can be inspired by a figure and then, you know, pursue a career based on that figure. And that is one of the main things that we're trying to accomplish with STEM Latinx, to provide Latinx youth a figure, a role model they can, you know, they can be inspired by. So the first thing that we saw, the first thing that I guess inspired me to create this program is the problem of Latinos in science. There we go. When it comes to Latinos in science, we can see, like, research has shown that due to family influences, low expectations, and the lack of positive role models, Latinx youth they're less likely to pursue a career in STEM. And specifically here in the United States, we know that about 18% of the entire population in this country is Latino. However, when it comes to Latinos in science, there's only about 6%, you know, our representation is about 6% in science. So you can see a big disconnect between how diverse the United States is versus how diverse science is. And that is one of the main goals that we were trying to accomplish, to raise that percentage of Latinos in STEM. So the mission of STEM Latinx is to empower Latino youth to pursue careers in STEM. And we are trying to do this by exposing them to positive role models, by giving them some, you know, cool experiences with science, and also by increasing their aspirations. And for everything that I'm going to present today, my audience for all of the things we did was the Verticlovers. And here you can see a few pictures of the Verticlovers. The Verticlovers is a local club here where I live in Manhattan, Kansas. And as you can see, they're all about middle schoolers and high schoolers, although we do have a couple kids in elementary school. And they are fantastic. They're about, you know, 35 to 50 Verticlovers. Most of them, in fact, actually all of them, come from low-income families. All of their parents didn't get a formal education. And so for the most part, when I talk to them, they don't have, you know, those like big aspirations. And that was one of the main things for me when I started STEM Latinx. I asked them, hey, what do you want to be when you grow up? And none of them, you know, mentioned, oh, I want to be a doctor or a scientist. And so that's where this project came from, because I wanted to give them, you know, an experience with STEM and STEM role models so they could see themselves as scientists. So everything that I'm going to talk about today, I did with this club specifically. So the way we are approaching the problem is we are giving them informal STEM education. So a couple of, you know, hands-on activities, and we expose them to science in like fun ways. We are giving them positive role models that are in STEM fields. And also we are trying to cultivate high expectations and high aspirations of themselves. And in this case, we specifically focus on like higher education. When it comes to measuring success, this was very tricky. But something that we did is we did like pre and post surveys, And we focus on this for like concepts. The first one is the number of youth that were interested in pursuing a career in STEM. As I mentioned at the beginning, that was 0. None of them had any interest, or they were just like afraid of pursuing a career in science. We also focus on the number of positive interactions with like STEM roles. So how many of them could think of really cool engagements that they had with like scientists? We focus on the aspirations, and as I previously mentioned, specifically higher education. How many of them were trying to like pursue some sort of degree, and how many of them were like afraid of pursuing that degree. And last but not least, we were looking at their conception, at the concept of like a scientist, where we would have them like think about a scientist and like write it out or draw it out. So how does the view of a scientist changes over time in their eyes? And for this, we divided the timetable, the activities into spring and summer. In the spring, we focused in STEM kits that you can see here. And then in the summer, we focus on the STEM day. And I'm going to be going a little bit more in depth. But something that I want to point out is that before any of this happened, at the first meeting in the spring, we gave them the pre-survey so that we could measure our success. And then at the very end, after the summer event, we gave them the post-survey so that we could see what were the effects of everything we did. So this right here is a picture of the STEM kits, and hopefully you can see, hopefully you can see that it's just very low tech, very simple. We made a lot of them, so we didn't have a crazy budget. So what we did is we had a small kit that had everything we could think of that would give the kids 3 hands-on activities, like science activities overall. And you can see that it's very simple, but it had great results. So me and a couple of other mentors went out and bought everything we needed for the kids, and we assembled them. And again, very simple. And what we did is we created 50 kits and we delivered them. And then we, over a course of 3-4 months, actually, we did a bunch of hands-on activities where we would meet monthly with the kids and explain the science behind the activities. And for the STEM kit specifically, here you can see how just a normal meeting would look like. We would meet over Zoom, and there are lovely folks in the meeting. So we actually created 2 different types of kits. So the first one, what we call the STEM kits, those were for the younger kids. And we had everything they needed to have, 3 hands-on activities, and we were looking at 3 different STEM fields with every activity. We were highlighting a different STEM fields. In addition to that, we created 25 older youth kits, and those we call the career readiness kits. And for those, we created kits with like pad folios and notepads and pens, anything that they could use for like, when you go to college, when you're going to an interview, things like that. And what we did is we met over Zoom throughout the spring, a monthly meeting. So we met 4 times, and we used the kits to, talk about science and things like that. Overall, what we did is we divided the Zoom meetings where the older youth would be in one room, the younger kids would be in one room, while the younger kids were doing the STEM activity. The older youth, we were talking to them about, how do you apply to college, how to write an amazing, one of the amazing summaries that you have to write, or, personal statement, things like that, how to apply for funding, how do you excel at an interview, things like that. So we were trying to prepare them for like the next level in their careers. We finished the meetings in May, and I have to say we were all really, really happy. We had amazing results, and the main thing for us is that they had, a way to engage, even though we were in the middle of the pandemic and they were from their home. Even from their home, they were able to do some science, and they were able to engage with us. So for the next activity, we had this STEM day, and this was like the capstone big project, and this we did at the end of May, now in the summer. And for the STEM day, what we did is we had an entire day of science exploration, and we highlighted 6 different STEM fields, and we had activities of all those fields. And here you can see just a couple pictures of the STEM day. So what we did is we highlighted we recruited a bunch of mentors from all different backgrounds, and then we highlighted a bunch of fields. So you can see here, we talked about plants, we dissected some animals, we did some microscopy with bacteria, then we talked about live animals, and we built some rockets, we did some engineering stuff. All in all, was an amazing and very fun day. And at the end of the day, we took the time to collect those surveys, the post surveys, and then we were able to analyze whether or not we had an impact on the kids. And we did. It was very gratifying to see, but when it comes to interest in STEM career, at the beginning, not a lot of them were interested in pursuing a career in STEM, but we saw that about 12% of the participants actually showed an interest in pursuing a career in STEM. When it came to role interactions, positive interactions with role models, we saw about a 30% increase in those interactions. When it came to the aspirations, but very specifically their interest in higher education, we saw that about 17% of the participants had an increased interest in pursuing higher education. And last but not least, when it came to their conception of a scientist, how they view a scientist, at the beginning, most of the answers were, a white male in a lab coat with like white hair. But then towards the end, we saw that about 25% of the participants described the scientist as, an underrepresented minority, be it, a female or Latino, just any of those categories. We just were happy to see minorities showcase, and just in this case, they were perceiving scientists as minorities. So super happy about the results. One of the things that I want to mention is that none of this would have been possible without the help of our community. And so when it comes to this, I just super briefly want to mention the importance of community ties. We were really, really thankful to these three organizations, but we were just grateful that they were able to partner with us. So the spring events and the STEM kits and the event, they were all donated by Mama Fans. They donated all the money for the materials for those kids. When it came to the STEM day, the multicultural engineering program at K-State donated everything, including the food for the STEM day. And when it came to the mentors for both the spring and the summer events, the Biology Graduate Student Association here at K-State, BGSA, they were the ones who actually donated the time, which is also really, really important. And they helped a lot in like mentoring and helping with all the activities. So super thankful, because these community ties are really what allows us to do everything that we did. But then in addition to that, I have to mention something very unexpected, but also our ties to the local newspaper, the Mercury, gave us a lot of exposure, which actually resulted in more people trying to, engage with us, but also donate their time and money. So it's been amazing so far. They were able to write 2 articles about the kids and the STEM day. And we were just grateful to them, because the results from those 2 articles have been amazing so far. And yeah, I just wanted to highlight that, like, it's very important when we have community ties. In the case of, this project, it was super important for us so that we could get it to happen, made it happen. But what comes next for us? So we are trying to formalize the program. Definitely, this was like the big like pilot project here, but now I'm trying to make it a little bit more formal and make it more adaptable. So that, my few goals over the next few months is to go ahead and build a website and create like a formal, probably a formal nonprofit organization, and then recruit a team so that, we can have an actual formal team and not just me in charge of everything. To do some training and, to train the mentors, and then to create a curriculum so that we can have more activities like this. And I pointed out making it more adaptable, because I focus on the verticalovers who are here in town. However, I'm moving in a month, so I need to make this adaptable for the next place I'm going to be at. And with that, I just want to thank everyone that made this possible. And I want to thank you for your time, and I'm happy to take any questions.
It's wonderful, Priscilla, and thank you for sharing that sort of personal thing at the end there regarding the just involving other partners, right? And I want to remind everybody, both you and Rosario are graduate students. You know, you're doing this and trying to finish up and graduate, right? So maybe my first question to you, just can you talk a little bit about that balancing act that you're doing?
It's been hard. Probably not. I'm not dealing in this in the healthiest way, because I keep like putting a lot of work here in the lab and then putting a lot of work outside of lab. But I've come to understand that honestly, having people like partners that you trust a lot helps a lot. So in my case, for both of these events, I have to give a huge shout out and highlight to Andy Ortiz. Andy is one of the other science mentors for the Verticlovers, and he actually was the person leading the STEM activities in the spring when I was leading the like career readiness activities for the older youth. And he was also my right hand for the STEM day. So definitely having someone that helps you.
That's right. And Rosario, do you want to share just your perspective on balancing act?
Yeah, for me, it's been pretty similar. It's hard. I end up working a lot of extra hours just on the weekends and at nights. And so it ends up being a little crazy. But one of the benefits is that, I mean, this type of work feeds my soul. So, you know, sometimes it's nice to have something that makes some of the trials of getting a PhD, it makes you feel a little bit better because you have something else that you can own and feel good about. And so that also helps. But yeah, it's pretty hard to balance. I've had to cut, I've also had to limit myself in how much I can dedicate to Pub Navigator work because I have to keep doing research. So at some point I just have to create a line and say, okay, you have to stop now. Time management has been a thing.
And taking care of yourself, as all of us researchers and practitioners, you know, we tend to overextend ourselves. So remembering to take care of yourself, and this is part of the reason for the symposium, is telling these stories on the field, right? Both you're struggling with data evaluation and yourself, your mental and physical health, right? Trying to do this kind of work. So thank you both for sharing that. Bruce in the chat here to Priscilla saying, another great presentation, intrigued by seeing another project working in schools. He knows of a startup in Chicago where they focused on engineering and math end of STEM. So that's a link there for you. So we are a little bit behind time. What I want to do now is, Bree, can we open up the breakout rooms? Because I'm sure some people have questions for Rosario and Priscilla, more directed ones. So you guys have about 5 to 6, 7 minutes, shall we say, very loose. And so jump in the breakout rooms, talk to them, ask them questions, maybe ping them for a collaboration potentially. And then we'll bring you all back here in about 5, 6 minutes. And of course, if you want to stick around here, you can, but I really encourage you to go and engage. Okay, so the timer starts now. Off you go. So Rosario, Rosario and Priscilla, go to your respective rooms, okay? And for those who are watching on live stream, hang tight. We'll be right back very soon in about 6 or so minutes. Yeah, and as a reminder for those who are still watching on live stream, my name is Fanuel Mwindi. I'm the Chief Resident and founder of SAI, and we are hosting this first SAI Symposium. And this is the beginning of our year, so we're trying to make this as an annual habit where we can get together and connect and see what people have been up to and share progress and setbacks as well. I think it's very important that we share those stories of the field. And so just briefly, SAI again is an incubator think tank connecting science and society. What we do is try to make it easier for practitioners and researchers to connect, engage, get support, funding, and all of that hopefully enables us to accelerate their work. And that's really at the core, at the forefront, is we want to make that easy for them to do their work and have bigger impact. And you can visit our website, stemadvocacy.org, to learn more. There's lots of information on the website, social media, you name it, lots of things out there. Bree, keep a look on the time. Let me know once we get to a point where we have to bring them all back.
Yes, will do.
And there's an advertisement on August 7th. Our next meeting will feature our interns that will be showcasing their work. August 7th, save that on your calendar. And they've been with us they'll be with us by that time, about 10 weeks. And they're working on some really interesting research proposals that they're building in the space of science communication, engagement, participatory science, co-production of knowledge. And it's been amazing to watch these undergrads really just grapple with the field and identifying interesting questions. It's a really hard task in finding those questions and articulating a plan to evaluate them and build a story. So join us August 7th.
Also, maybe you want to plug the C6 applications?
Yes, and also, yes, so we have our next fellows program, cohort 6, that is now available online. So just go to stemadvocacy.org/SAI fellows, and you will find information about the program. It is a 10-week program focused on practitioners who have early stage ideas, and they're looking for mentorship, advice, and a little bit of funding to launch those ideas. And the capstone project is the pitch day. You can also look at on YouTube, you can search our previous pitch days. We've had a couple of them now, and you can see what people are pitching and presenting. It's always exciting to watch these projects come alive over 10 weeks, over a really short period of time. So check it out. The application is open. And that targets really graduate students, postdocs, really, and then we are opening it up now to more people. Okay, really at the fundamental level, it's about the idea. Okay, that you have. The idea is what really propels us to pick those people and help them launch them. And international can also apply. We've had fellows from the UK, Israel, Kenya, and we're looking to broaden that even further. Yeah, just read a couple comments here from Bruce. So for anyone interested in formal analyses of geoscientist exercises, see Chamber 1983, as well as some of the critiques of how the coding scheme works. So there's a link there, geoscientist test, and some methodological issues, geoscientist tests, some more links there as well. So take a look at that link that is available. For those of you in the live stream, we will put these up after the live stream is over. We'll put them in the description for the chat. Unless, Bree, are we able to put the links on the chat? Is it, I don't know if it's, we figured out the issue with the live stream chat.
Unfortunately, not yet, but we'll still work on it.
Okay, yeah, we apologize for that. It's something we were hoping would work today, but as you know, with these things, technology. Okay, so we are seeing a lot of people having some really interesting conversations. Rooms are pretty, that's good. Thank you, Bree.
All right, I will go ahead and close the rooms, and then I think they get a 60-second buffer warning. So
yeah, thank God they get that. It's not like an immediate shutdown of things. So So I'll just, yeah, I don't need to share my other slides at this time. The cool thing is if once they come back and they still want to chat, so we have a chance later on, and the Gather Town will present an opportunity for that. So a little taste of this. Okay, welcome back, everybody. I suspect all of you were in the midst of some really interesting conversation. We had to pull you back. So hold those thoughts because there'll be plenty of other chances to engage. 2 more, in fact, to be exact. Okay, and at the end, if you stick around, you'll have plenty of time, infinite amount actually, to continue chatting as long as people are available. That room will remain open and for everybody. Let's see, we're still waiting on some, right, Bree? Yeah. Oh, is everybody back? Everybody's back? Okay, everybody's back, sorry. Okay, so I'm very excited to welcome our next section, really focusing now onto the research side of things. Hope you saw in the first part where we heard these stories from practitioners who are telling us, the news and updates from the field on the ground. So I'd like to introduce our next speaker, Dr. Peter Vollbrecht. He's one of our senior residents here. And a quick background story, he was the first fellow in SAI, first one. I can't believe it, I can get to say that, and he's been with us ever since. There's a random tweet, I think, when I asked anybody working on some interesting project, and he replied through Twitter. And ever since, we've continued to collaborate. He's a mentor for the fellows and has given a bunch of talks to our work, and he's doing some phenomenal research, both practice and research. He has a really unique angle where he publishes some of the work that he does. And so really excited to hear from you, Pete. And just as a quick background as well, Pete is an assistant professor at Western Michigan University School of Medicine. Pete, the floor is yours.
All right, can everybody hear me?
Yes.
Awesome, and we'll present from the beginning. We'll start here. All right, so thank you for that introduction. It has been so much fun to be a part of SAI. Absolutely, I responded to a Twitter of Fanuel's at one point that said, "What would you do with $100 if you could right now have $100?" And I responded, and I think Fanuel was somewhat surprised that I had answers to a lot of his questions as to like, why, what are you doing to really make sure that what you're doing is working and all these sorts of things. And so that was the start of a great relationship there. Today, I'm going to talk a little bit about the Brain Explorers program that I've developed along with some colleagues at Western Michigan School of Medicine. And really, as Fanuel suggested, this idea of getting scholarship out of our outreach. And so scholarship from outreach, water from a stone or a sponge is the name of my talk. A lot of times we think of this outreach things as something that we're doing that's extra. And it's definitely how it's viewed in academia in many places. And I would argue that there's a lot of scholarship opportunities that are there through the outreach that we're doing. So a little bit about Brain Explorers. It's our mission to provide exciting and engaging, and I've bolded accessible and accessible as kind of our 2 emphasis points, science engagement for underserved and underrepresented populations. And really the problems that we're trying to address are a need to provide better science opportunities for underrepresented and underserved populations in science, and also this idea of decreasing trust in and access to science within the general public. And those to me fit well under this idea of accessible. Is the science accessible to people? And then also trying to address this idea of accessible. And that really stems from this fact that there's really a lack of studies demonstrating what effective science outreach really looks like and what it is. And not that it's not happening, but there's not a lot of studies out there that are saying like this works, this doesn't. And so we're trying to address that to some extent as well. The way we're going about this is through our Brain Explorers program. And so we've been teaming with local schools as well as our Pathways programs, which are basically programs designed to maintain and keep students interested in sciences, and particularly at the med school, trying to get them into healthcare or health-related fields. And we've done that by creating and assessing our neuroscience outreach. Both Dr. Porter-Stransky and I are neuroscientists by training, and so that's where our interests lie, and that's the only reason this is through the neuroscience lens, not anything to do with neuroscience being a more important topic for students to be learning or anything like that. So here's some pictures of us pre-pandemic, mid-pandemic, and late pandemic, the way that things have been here in Southwest Michigan anyway. So pre-pandemic, we're all hanging out playing with sheep brains and things like that. Mid-pandemic, we transitioned to online, remote events where we basically had students working through cases and things like that, trying to understand neuroscience concepts that way. And then late pandemic, we started to be able to come back, but they only let one person of our group come and join them. And then the teacher was there and the students were in person. I know that's different than many places on either sides of the United States, but here in the Midwest, they're letting us do a little bit more. So that's been really nice. Some of the data that we've published already has to do with this kind of accessible part. And one of the questions that Andy Gall and I had, but this was actually back when I was at Hope College, not at Western Michigan, was really understanding who are we reaching when we're doing our outreach. So a lot of times I've been involved in science outreach activities where we say, hey, like we're gonna have a community day and we're gonna invite the community to come to our school and check out what we do. And I think that those are really valuable. Don't get me wrong. I think that those open house style events are very, very valuable in terms of continuing to engage people who are already interested in science. But I think when oftentimes we state that the goal of our outreach programs is to reach people who aren't interested in science or don't trust science or these sorts of things or don't have access to science. And I think those are the people that often we say we want to reach. If we look at this, when we look at just the demographic breakdown of who we're actually reaching, when we say open house participants, we were getting 71% white or Caucasian participants, and these were only measuring the middle school students that attended those events, because we went to school visits, and you can see that number dropped significantly down to about 45%. In Holland, Zeeland area where I live, our Hispanic, Latino, Latinx community is roughly 45%. And so we were not really seeing anything close to representative of that with our open house participant, but we see closer to that with our school visit participants. So again, not surprising that we're reaching a more diverse group of people, but no one had ever published something like this before. So this actually we published in the European Journal of Neuroscience. So again, encourage you guys to really think about what you're doing and has it been done and can I actually quantify this and publish it? Because I think for many of you, especially some of our junior residents who are still in grad school and doing other things, like this is a stepping stone and can further your career while also helping other people. This comes towards these science attitudes. And so again, not just demographically in terms of race or ethnicity, but also just in terms of overall interest in science. We're reaching people who are less interested, have lower science attitude scores when we do our in-school participants than our open house participants. And again, this isn't shocking to anybody. You would expect people who show up to a science open house to be people who want to be there and want to be engaging in science. But I think if our goal is to be reaching those who are less interested, schools where we have a captive audience is a better platform. On these other two graphs, there was no major difference between male and female in terms of these things. And this last graph really just highlights the fact that we don't have enough diverse participants at our open house event to really make any statistical claims from that. So really highlighting that we're not reaching as diverse an audience either in science attitudes or demographic. So the other side of this was kind of this accessible part. And so this is just one example of what we're doing. So we had one lesson where we had a slideshow for a very short number of slides showing kind of the lobes of the brain and what their functions were, and kind of walking students through that, having them work through some worksheets and kind of writing some stuff down. And then we had 3 hands-on activities, an active learning and memory activity, as well as a sensory processing and a sheep brain dissection to kind of reinforce some of these things. We had them take 2 assessments or surveys, one before we showed up and one after. So we had an attitudes towards science survey and 2 free response questions. That was what they had to answer. And again, they took it before we showed up ever, and then they took it 2 weeks after we left. We had one of those free response questions very tied to the content that we presented. Sorry about that. And then one that was not so much directly discussed, but somewhat related. Investigators were blind as to what the responses were. So this is the Science Attitude Survey. It's a survey that's been validated. So if anybody wants to use this survey, this is another thing. If you haven't done a lot of social sciences, validated surveys are particularly important. When you're publishing things, people want to see validated surveys. If you're interested in this, let me know, and we can get the full survey to you, or you can use just the smaller part that we've been using. But these are the questions that they've been asked. And then these are the content questions. What part of your body is important for making new memories? Be as specific as possible. Now, I should have pulled some out to kind of show you the difference between pre and post. But if there was no answer or it was an irrelevant answer, they got a 0. And if they started talking about, multiple brain regions being involved and working through memory consolidation, they would get a 5, which I don't know that we got any 5s from our middle schoolers, but we had to put it out there as a possibility. And then the question that was more of a control had more to do with reflexes, which we didn't really talk about in this particular lesson with these students. When a person touches a hot iron, describe what causes the person to move their hand away. We do have some lessons where we use this, so this would then swap with the other, with this being the kind of content question. I'm sorry, my slides keep it pre-advancing on their own. But so we can swap them out and without having to make major adjustments to our assessment. Ultimately, what we showed here was that, the stuff that we covered was well received, and we saw significant improvements, and the things that weren't, we didn't really see significant improvements. And this isn't, again, no one in this room is going to be like, oh my gosh, this is mind-blowing. It's not at all mind-blowing. It's exactly what you would expect to see, but it's assessing your own outreach. And if we don't see this, as I can certainly point to some cases where that wasn't the case, we can say, oh, we didn't do that quite as well as we thought we did, or how can we do this better? So it's always really important to be assessing your own work. And in doing so, it's sometimes possible to also publish that work. So what are we doing right now? One of the big things that Brain Explorers is working towards right now is creating kind of template lesson plans for the lessons that we've been putting together. And this is just an example of that template. And then basically I give this to our med students when they've created a lesson, and they have to fill these out and fill in all the different blanks and everything else. And the ultimate goal is to be able to put these on a website as a repository for people who either want to do outreach, or for educators who want to do some sort of a lesson but don't want to have to put all the time and effort into figuring all the things out. And one of the really important parts there is this preparation resources for instructors. This is where we can post YouTube videos that they can watch to kind of brush up on content and other things, or articles that might be useful, that are really helpful for the instructor themselves. as they get ready to do this class. And I would say another really important piece of this that is often missing in outreach is kind of this phenomenon and driving question, as well as learning objectives. What's the purpose of the event that you're putting together? What is it that students are supposed to learn by the end of it? And a lot of times we go out and do outreach with this idea of like, isn't this going to be exciting and fun? And that's not a bad thing. That can be an objective, is that students get more engaged in science, but it's not really the lesson objective. It's the lesson of the program overall, but it's not like a lesson objective. Every lesson should still have kind of a goal for what the students are getting out of it. And then the phenomenon or driving question, this is very much a K-12 education mindset of things, but like, what's going to be that thing that catches them? So if you're going to talk about the brain and how it works, we used stroke as an example, and we show a video of a person who's in the middle of having a stroke. It's very engaging and kind of grabs them. And then you start talking about like, what the heck is going on in the brain? So what is it that can drive that student inquiry? And then having a timeline so that people can kind of walk through what is it that I'm supposed to do when, and it's adaptable, but at least there's something there for them to use without having to put a lot of extra thought and effort into creating the lesson. So I think I'm probably over time already. So the future directions is to host these lesson plans on a website for others to use. And so we're in the process of putting that together now with WMed, where I work. So they're on board with us doing it and hosting it there. I'd like to have roughly 10 lessons completely put together and maybe even tested before we actually launch the website. So there's a reasonable amount of content for people to pull from. And then using those lessons plans to kind of create pathways or longitudinal sets of lessons that teachers could be using as well. And then another thing that we are doing is evaluating the effects of this outreach on the medical students who are doing it, and continuing to assess our outreach ourselves. And we would love to grow by recruiting people to be part of Brain Explorers and doing stuff elsewhere. So if that's something that's engaging or interesting to you, definitely let me know. Real briefly, what we see with our student instructor impact is that they feel like it's helping them to explain concepts to non-scientists. It's helping them just in general being interested in communicating with non-scientists about science, and that their communication skills are improving. Some quotes from our medical students. As medical student, it's beneficial to be teaching and explaining the topic, because it can be difficult to explain things, but I also think it helps me as a medical student better learn the content when I teach it. So that's a benefit to them specifically, just in terms of how well do I know this stuff. But then also things like, I'm going to have to be able to teach my future patients, and learning how to communicate science at a lower level than what I'm learning it at is actually really valuable to these people. So again, thinking about who might be actually affected by the outreach that you're doing. And it's not always just the people with whom to whom you're reaching out. So I think that's another way that people can use their outreach to consider scholarship. And I'll leave you with this, which is just to encourage you to really consider how your outreach can be translated into scholarship that helps others do what you do, but also helps you advance your career. I think especially when people are doing outreach, there's this sense that like, it shouldn't be about me. It shouldn't be for me. It should only be for the people to whom I'm trying to reach out. And I would encourage you to consider that it's completely okay for it to be a very altruistic endeavor for other people, but that you can also get something out of it for yourself, and that there's nothing wrong with that. So I would encourage you to consider how your outreach can be translated into scholarship. And
awesome. Thank you, Pete. So we are running a little bit behind time. We have time for one question. Remember, we'll still have a little breakout room as well. There you can chat with Pete if you have additional questions. Questions? Okay, if they're not, I would say, Pete, this question of scholarship, translating the work you do to scholarship, I think is fantastic, right? We tend to forget that, and there are some challenges, of course, right, in doing this kind of work. And so can you speak maybe very briefly about those challenges that you faced and where you, how you've tackled them?
Yeah, so I think one of the really important things is when you want to translate these things, there are certain hoops that you have to jump through in terms of IRB protocols and approvals and things like that. And so as soon as I would encourage you to establish a relationship with people that you're doing that outreach with before you then come and say, hey, here's this bunch of things that I would love to ask your people questions, because it just looks intimidating. I've had people just kind of back out of things because I've gone to them and said, here, we want to do this study with your students. And they're like, wait, whoa, no, you're not doing studies on our students. So kind of developing those relationships before approaching people, but knowing that you have kind of those hurdles that you're going to have to jump through. And I'm happy to chat with anybody who would further, who'd like to know what some of those are, but IRB is probably a big one.
That's exactly right. You know what I was going with that. The IRB is the big monster with that. Please drop your questions to Pete in the chat as well. I think Pete, Rosario may have a question for you, but we'll keep moving here. And actually, that's a nice segue to thinking about policy. So you've seen the practice, you've seen the research that could be done. Something that we shouldn't forget as well is that you can look at this problem from a policy angle, right? This connection between science and society takes shape in many different forms. And so what we're trying to do with SAI is tackle it from multiple angles. Because I think this is the only way we're going to be able to sort of move that needle and see change across the board, right? So with that, I want to introduce you all to Adriana Bankston, Dr. Adriana Bankston, and she's one of our senior residents here at SAI. She does a lot. She's a principal legislative analyst at the Office of the President at UC, University of California. If that's not enough, she's also the Chief Executive Officer and Managing Publisher at JSPG, the Journal of Science Policy and Governance. And of course, with us, she is also the Biomedical Workforce and Policy Research Investigator. Adriana, I don't know how you do it all, but I'm excited to hear a little bit about what progress you'll be making. So you're going to be talking to us about achieving data-driven impact in science policy as an early career scientist. Adriana, welcome.
Thank you. Thanks so much for having me. It's exciting to be here for this first symposium. I've enjoyed the other presentations as well. So what I'll be telling you about today is a little bit broader around science policy because it is a very broad field. There are a number of different ways that you can impact it. And just to really drive this point home that as a young scientist, you can really make an impact in this field. So I'll explain a little bit about what it is. I just have to give this disclaimer that this is my personal view, not my employer's. So I just wanted to start a little bit about how do we actually define science policy. So it's defined as the allocation of resources for the conduct of science towards serving public interest. So it's very broad. Some topics that might be included here are the funding of science, careers of scientists, translating discoveries into technological innovations. And a lot of this ends up being around sort of commercialization, economic growth and development, competitiveness. And again, depends on sort of the level that you're looking at. If you're looking at sort of local, state level, national or international, which comes down to sort of the competitiveness between the US and other countries and different topics and so on. So there are a lot of things that are called science policy, which is why it's a little difficult to sort of pinpoint what to do. But I wanted to give you a flavor of the different things that you can do to impact a specific area that you might be interested in. So you might be wondering, what is science policy and why would you engage in it? So I think, as obviously my interest has been around sort of empowering students and trainees in policy, and through my own transition, trying to think about how we might improve the research system. And part of what we're doing here with SAI as well is how do we use policy to bridge the gap between science and society. And so what I found through science policy is that it really gives you a broad view of looking at specific issues and understanding the world and possibly sort of bigger picture impact that you might have sort of in your just working in your research in your lab. So it really gives you sort of a broad level view of issues and allows you to really make a difference in an area that you're interested in and working on really, I think, high level important societal problems. a lot of policymakers actually don't have science background, so they do rely on scientists to bring data to the table that informs what their decisions are like. And finally, the decision of what it means to be a scientist, I think, has expanded a lot, especially during the pandemic. It really helps you engage more in the community and, again, have sort of bigger picture impacts on specific topics that are overarching across different sectors. So you'll see what I mean by going through specific ways to do this. So one way in how I got started through this nonprofit called Future of Research, won't go too much into it, but we essentially advocated for institutional change for early career researchers and their voices and opinions being heard and having an input in institutional policy. So this is sort of the grassroots way of doing things that we did events, published the data, and sort of, again, try to get the opinions of young people out there in relation to academia. One paper here, you can see we published this around a mentoring meeting that we had about how do we improve the training system and what do students say about it. The data-driven portion here, which is related to looking at postdoc salaries. This was a nationwide study to look at the impacts of a federal labor law on postdoc salaries. So you can see here on the left, we looked at institutional data, and on the right, we actually try to get salaries from institutions as far as what they look like nationally based on the titles. And so this actually was impactful in that we're able to increase postdoc salaries at a few institutions. And this was, again, it's really nice to see that trainees are able to make this sort of difference in institutions sort of in a grassroots fashion. So if you think about this, top down. And then the other things I'm going to tell you about are sort of more higher level, the sorts of things that I work on. This is one, these are very typical sorts of things you would do as events for Hill staffers. So for example, we did this briefing with postdocs and students that talked about the impacts of the pandemic on their research, and sort of used this to highlight the need for research funding and recovery. And it's a really nice way to sort of make an argument for why we need to support the next generation through these sorts of events, which would normally happen on the Hill, but were virtual. Another way to do it is to write responses or statements. So this was a request for information from NSF. They were looking for responses for their strategic plan. So we wrote this section about why NSF should diversify the STEM workforce, and this was included in a response by AAU, actually. So again, for somebody who's sort of early in the process, it's nice to be part of the community and submit something like this to NSF that they actually will receive. So that also is impactful. Another way is through legislation. So this just recently happened mid-June. I work for University of California. So you may have seen this NSF for the Future Act bill that just passed the House recently. And I actually wrote this amendment to include postdocs in a section in the bill that provides professional development funding in addition to graduate students, and it was introduced by Lofgren. So it's now in the bill, passed, as I said, it passed the House. And this is, again, another way to impact the pipeline through legislation in ways that obviously this sort of thing can happen. And so that's pretty exciting that the language is now included there. So this is, again, very high level, sort of top down. And then, I wanted to just bring up the journal a little bit, because this is another way for you to think about impacting policy through the research that you publish, and give you a little flavor of the things that we work on. So we published an issue on climate change solutions with the United Kingdom Science and Innovation Network. Again, all these are all publications by trainees, students, and postdoc policy fellows, and it's a good way to get your views and opinions out there in policy on topics that are really timely. And then we'll have two other issues coming up that will be published in August and September. One is on shaping the future of science policy. Again, what does this look like? This is funded by Kavli, and again, trying to sort of get the the views of young people out there in terms of the future of the field. And then we also have another issue on intersectional science policy, which is very much focused on diversity and will be was very popular and will be coming out in a couple of months as well. So again, the journal is another way to sort of impact policy through your writing. And then as far as SAI, so you might have seen this, we're building this policy lab. Again, thinking about cultivating the next generation workforce in science policy through doing research and training for early career researchers from all backgrounds. And my interests, as Fanuel mentioned, have been sort of at the intersection of all these areas of research, higher education, policy advocacy, as well as workforce development. So it all sort of comes together here in terms of what we might be able to build. So as you saw that, this is very broad. One of the things that we're looking at is publishing sort of a landscape paper on looking at what sort of programs exist, where the gaps are, how do we help students who want to get into this field from different backgrounds. And again, this sort of publication, I think, will help us figure out what we need to focus on more. And then obviously looking at some programming that we might do some similar symposium maybe to what we're doing here, or more of a course sort of thing where, again, we'll be doing something every year to build sort of the policy portfolio for SAI. So these are sort of things that we're still thinking about. Happy to take your suggestions about this, but I'm excited to see what we can do in the future. And then I'll just leave you with my contact information. I'm happy to connect with you on LinkedIn or Twitter if you'd like to chat more about policy or any topics that I discussed today. Thank you.
Wonderful. Thank you so much, Adriana. Questions. The policy angle is something that we want to push more and we build it out. So we're very excited to have Adriana with us. But yeah, questions, especially if you start fusing it with science engagement and thinking about participatory science, co-production, policy, I think is right up there, right? And you can make, as Adriana suggested, you can make a lot of impact by changing policies, right? Because that trickles down quite effectively. Any questions? If not, we can go into our quick breakout rooms. And this should be a good break before we hear our keynote from Dr. Lewenstein. So Bree, do you want to set up the breakout rooms? Perfect. So you guys should see a ping there. Please visit both Adriana and Pete. Please join the breakout rooms, and we'll have about 5 minutes so people can engage with you, ask you questions, collaborate. So the breakout rooms are open. Enjoy. Please take advantage, okay? Please take advantage. And for those of you that are live streaming, again, thank you so much for sticking with us and joining us. My name is Fanuel Windy. I am the Chief Resident here and founder of SAI. We are in the middle, or towards the end of our first SAI Symposium, first one ever. So really excited to have you join us. At the moment, we are in our second level of breakout rooms where our participants here are chatting with our two presenters, Dr. Vollbrecht and Dr. Bankston, regarding their work. Shortly, we'll be having Dr. Lewenstein from Cornell University, who will be sharing with us the keynote presentation. And I will make that introduction shortly. So join us, stick around, and we'll be going live in 3 or 4 minutes. And as well, okay, I guess we'll wait for everybody to come back. I've dropped in the chat here the link for our review. We'd love to hear feedback on today's session as we will begin planning next year's symposium very shortly. Not too soon, Bree, but that's something that we will be, we love to get feedback on all our events. So please use that link and let us know.
Do we have a QR code for the ends for that?
You know, I do not, but let me do that right now.
I'm just thinking, since we unfortunately can't post it in the YouTube chat, it would be maybe helpful for folks watching the live stream.
That's a very It's very, very true. So yes, I'm gonna make that available right now. Bree, do you have a timer going? I kind of it roughly.
I do. It's been about 3 minutes.
Okay, great. So, oh, great. Bruce is back already. And again, for those who are streaming or watching this later, please visit our website, stemadvocacy.org. If you're interested to learn more about the different projects that our residents and fellows and interns actually are working on. They are all working on very diverse projects, and part of our focus has been to diversify the level of projects that are going on with a core mission that we're all targeting this connection between science and society. So for us, finding that common thread and points of collaboration, engagement is really at the focus. And so these presentations and meetings that we do are really geared for us to find those common points of engagement and allows us to further accelerate what we're doing. Because we fundamentally believe that working together, we can move the needle much, much further than working alone. So that is what drives us, and through all our events, that's one of our core mission as well. Through the breakout rooms, through the presentations, and actually through the platform later, we'll deploy the Gather Town. And we do this, we have this quarterly collab exchange, whereby we invite external folks and internal folks, and we have a little dating scene going on, dating game, where every 10 minutes we rotate, meet someone new you haven't talked to, okay? And we do this every 4 months. And so the idea is to, again, create those opportunities for collaboration and engagement. So check it out. It's called Collab Exchange, X, just the letter X in the middle there. And Bruce, you're always welcome to come to those anytime. Okay. Do you have everybody back, Bree? I think
5 seconds, everyone will be back.
Oh, okay, great. Okay, so welcome back, everybody. Very excited to welcome our keynote speaker for today. So hopefully you've seen a really small snippet of a journey from the practitioner side, from our junior residents onto our senior residents who are working on these research topics, broadly speaking, policy side, scholarship side, even at the level of science communication. And so we felt it was important to also have someone who studies this and looks at the bigger picture, the historical view of what's happening, what has happened, what is happening, and where are we going? And Dr. Bruce Lewenstein from Cornell University is that person. And I was so glad that I got a chance to give a presentation in his class back last fall. And that's how I got connected with Bruce and sharing my story to his students. And when it came for this symposium, his name came up very quickly. And I'm like, it'd be awesome if he could make it. And surprisingly, he was available. So Bruce, so thank you so much for being able to make it. So I would like to put this up so everybody can sort of see. And his talk today is why public engagement is and always has been and always will be critical for science. Dr. Lewenstein is a professor of science communication and former chair of the Department of Science and Technology Studies at Cornell. trained as a historian of science. I love that field. He works across the field of public communication of science and technology, including informal science education, citizen science, and communication training for scientists. Please do Google him, look at the work that he's published, or visit our library. Some of his work is required reading, I think, should be anyway. And so as I would like to welcome him, and please, for those of you watching it, you can scan the QR code here. We'd love to get your feedback on today's symposium. And I will introduce this QR code again soon enough. But Dr. Lewenstein, Bruce, should I call you? Welcome.
Please. Yes, please call me Bruce. All of you, please call me Bruce. Thank you so much for the invitation to be here today. Faneuil, I have to tell you, it wasn't last fall. It was a year ago spring, because you were originally supposed to come speak to my workshop in person, and 2 days in advance before was when the world shut down, and your university no longer allowed you to travel.
Amazing. Time warps.
Time warps. Yes. Okay, so let me get the proper screen up here. That thing we all do in Zoom world. It's really great. Again, thanks for the invitation. These have been really fascinating talks. I've really enjoyed listening to hearing things. I hope that the various comments and resources I've put in the chat have been helpful and not intrusive, but they really touch on a lot of different issues in the broad world of science communication. I want to begin with a land acknowledgement. I'm speaking to you from my home in Ithaca, New York. Both my home and my institution, Cornell University, are located on the traditional homelands of the Gayokono, the Cayuga Nation. The Gayokono are members of the Haudenosaunee Confederacy, an alliance of 6 sovereign nations with a historic and contemporary presence on these lands. The Confederacy precedes the establishment of Cornell University, Ithaca, New York State, and the United States of America. We acknowledge the painful history of Gayokono dispossession and honor the ongoing connection of the Gayokono people, past and present, to these lands and waters. What's important about reading and land acknowledgement is not that it's a formula that we now just stick at the beginning of a talk, but it's something that reminds us of, or gives us an opportunity to reflect on a variety of issues about the resources we're building on and the obligations we have to the people around us. And I think that kind of reflection is really critical in a field like science communication, where we are just beginning to bring lots of things together and where we're beginning to recognize some of what we've left out. And so for me, having a land acknowledgement is actually a powerful part of thinking about my own professional work. To begin, we have to think about, well, I've used this term science communication. What do I mean by that? Typically, when you hear the word science communication, you think of it as this linear process, right? You do whatever you do in the lab or the field. You go to meetings and you present. Depending on your field, you may circulate preprints. There's some grant activity that happens both before and after, and so on. But finally, it gets published in the formal paper. And when that happens, that's when it's science, right? Is when it's formally in that paper. And then it goes out into the media or into the textbooks or into the classrooms or into the policy world, or all of the various things that we've heard about today. It turns out when you do research on the field that it's a little more complicated than that. Don't worry about the exact details of this. I think you can still see, I think you can see my cursor, you can still see the lab and the field, and there's journals, and it goes out to the news media, but there's all kinds of other ways that information flows. If you give a talk, there may be a reporter there who writes about it, or maybe a policymaker hears about it, or you build an exhibit for a museum, and that gets talked about in a church basement, which then leads to some kind of general public discussion. If you're doing work that is environmental or ecological, you may be at a nature center and have people directly asking you questions about your work. All these ways in which these things interact. And you'll also notice that the arrows are double-ended. Information flows in all kinds of directions. And so these various public interactions are as fundamental to the flow of information in science as that linear process, which is in there, but it's a lot messier. Depending on the resolution on your screen, you may be able to see an XYZ axis in there. I call this the sphere of science communication. It's, as I say, the details aren't important. It's the conception of science communication as being this multi-dimensional, multi-directional kind of thing. Now, already in this talk, I've used the terms science communication and public engagement with science. There's a third term that gets used to describe this called informal science education. And is this diagram that was prepared a couple of years ago by the American Academy of Arts and Sciences shows, there's tremendous overlap between these fields. And if we don't want to get too caught up in precisely which label are we using, but it is a little bit helpful to see what some of the differences are, to understand why people are using these different labels. So some people are thinking more on the educational side. These are often people in museums, but not always. Often after-school programs or educational documentaries. They're trying to teach. They want people to learn something. There's a separate world, the science communication side, that tends to be the journalists, the institutional public information officers, and yes, your institution has one. That's a direct quote from a PhD comic that everybody should know about. I should have provided a link to that. And the whole thing often goes under the label of public engagement, and those things in between the informal science ed and the science comm often are ones that carry all three labels: public engagement, ISE, SciComm. We could have endless arguments about where to put these things, but I think it's important to recognize these overlaps and so forth, and to recognize that this has been going on for a long time. So here are two kinds of public events. One is a lecture by Michael Faraday, Sir Michael Faraday, at the Royal Society in London. We can't quite tell, but over on the far left is Prince Albert, the husband of Queen Victoria. This was something the elites did. This was something that you were supposed to do, was listen to experts. A more modern science fair, Maker Fest happening there. This happens to be the Philadelphia Science Festival. Kids interacting, working with some of those kits that we just heard about, and so on. There's also a lot of just delivery of information, sometimes with opportunities for feedback. So if you think about the Facebook site IFLS, as the woman who started it says, I will say the full name once: I fucking love science. I won't say it again because I don't know who I've just offended. But I don't know, the last time I checked, there were 25 million subscribers, which means that when you count all the people who then follow on feeds, there are 70 million people who see a post there. Emily Grassley's Brain Scoop, she worked for the Field Museum for about 7 years, doing a wonderful YouTube series exploring various topics. And of course, there's discussion that would then happen in the comments section. I pointed to the Philadelphia Science Festival. There's the World Science Festival in New York. There are science festivals all around the country. We now have a much more kind of interactive way. And so part of the question is, how did we get here? And where why am I saying that science, the practice of science, has public engagement built in? I think it's easiest to see that if we think especially about museums. Museums which started in the 15th or 16th century were called originally cabinets of curiosities. They were just collections of odd things, rocks, feathers, two-headed goats, whatever people found, they would put together. And it wasn't until about 200 years ago that people started trying to organize them, and we began to get something that where there was systematic knowledge. And interestingly, one of the first and most famous of the museums in the US, Peale's Museum, used the Linnaean system as a way of organizing what was being presented. But there was still this question of, is this about doing research or is this about doing public presentation? Two of the most famous of our museums, the Smithsonian Institution in Washington, or the American Museum of Natural History in New York, notice the language there. The Smithsonian was created for the increase, that is research, and diffusion, public display of knowledge. And the history of the Smithsonian is that in its early years, it was all about research. There was very little public display. There was a lot of tension around that. Eventually, it became the mix that we have today of both the very famous museums, but also world quality research sites as well. Similarly, the American Museum of Natural History was originally created just for research purposes, to house research collections. And the very famous public displays that they have came along later. Also, if we're thinking in the 19th century, we begin to get much more of an education for the masses. When I showed the Faraday drawing, remember I said it was for the elites. Through the 19th century, there's much more attention to public schooling. There are public lecturers, the media, the newspapers become available to ordinary people around mid-century, partly because literacy becomes more common, but also partly because the printing process changed and you could produce a newspaper for a penny, or magazines intended for inventors and so on. But one of the challenges here was, are we trying to provide information or are we trying to provide spectacle? And this was another one of these constant tensions that is part of the field. By the beginning of the 20th century, we started having much more professionalization. So you had public health campaigns and people who specialized in public health. Obviously we see that again now, 100 years later. This was tuberculosis. There were some of the original vaccine campaigns were around that time. We also got people who had the profession of science communicator. This is E.E. Slauson, trained as a chemist, wrote a textbook called Creative Chemistry that was available in most high schools in the country, and eventually became the first editor of something called Science Newsletter. It's still published. It's called Science News today, and was originally created as a way of distributing science news to newspapers around the country. Eventually, some of its activities changed, but many of them are still involve various kinds of science outreach. What's important partly about this period is that science was really seen almost entirely as a positive thing. Science was for progress. And so science was idealized and science was held up literally almost like a religion. The fact that these science museums are such monumental buildings is not accidental. That they were intended to show the value of science. There were people who moved around between them. Waldemar Kempfert was an editor at Popular Science Monthly. He was the first director of the Chicago Museum of Science and Industry. He ended up spending about 30 years as the science editor of the New York Times. don't know if you'll be able to see this, but his papers recently got donated to Cornell. This is one of his awards that that he got, a big statuette that they donated his papers. They gave us that as well. It's very heavy. That belief in progress was part of the culture of mid-century, mid-20th century United States. This is the frontispiece for a book called Man in a Chemical World. And it says, chemical industry upheld by pure science. Unfortunately, I've got something covering this. Hold on a second. Chemical industry upheld by pure science sustains the production of man's necessity. We'll set aside the gendered issue right now. But you can see that idea of progress. But there have always been, especially, I mean, in the 20th century, concerns about the effects of science and technology. So early in the century, worries that industrialization and that came with technology was leading to people being literally crushed. So Charlie Chaplin in Modern Times. With the arrival of nuclear weapons and at the end of World War II, people were worried about what would happen if we had a nuclear war. This poster about what to do if you see a flash of light. I'm old enough that I remember in school being told what to do in terms of if there was a nuclear attack. Today, we know there's nothing you can do. The environmental movement, now more than 50 years old, was very much about critique of some of what happens in science and technology. And this is part of what led to this recognition of the science and society interactions is part of what led to the real fluorescence of a lot of outreach especially beginning in the 1980s, where you got popular science magazines and television shows and popular science books and plays, and it became something that was more clearly a part of our culture. In the interest of time, I'm going to skip that one, just go directly here. These issues were wicked problems. This actually is a slide I originally prepared some years ago, where vaccines and autism was a wicked problem. Now, obviously, I have to add COVID to that. The point is, these are issues that involve much more than just the science. These are problems that involve technical questions, policy questions, personal values, religious commitments, concerns about the world changing too fast, all kinds of new and emerging technologies or diseases, things that change. These are problems for which there is no simple answer. And so they are wicked problems. So how can you deal with that? And what we've learned in the last 30 years as scholars is that there's two basic approaches to addressing these. One is what's usually called the information delivery or deficit model mode. This is deliver information, whether it's about climate or science education or evolution or about vaccines. People saying, here's the information you need to know. The problem is we've learned that that's not always, in fact, frequently not how we address public concerns, because there are often very good reasons that communities are questioning science. The most obvious case here is the question of vaccine use in the African American community in the case of COVID. As many of you know, there's a terrible history of racism in institutionalized medicine. The Tuskegee experiments of the 1930s through the 1960s, actually 1972 before it formally ended. There are very good reasons why people in the African American community would be suspicious of institutionalized medicine, and therefore there needs to be various kinds of discussion to build trust, to understand what people's concerns are, and to figure out how you can find common ground. Now, in the research world, we talk about these as separate things. There's the information delivery or deficit model, and there's various kinds of public engagement models. That's a whole nother talk, talking about all these models. The part of the issue here that you as people moving into this field have to think about is that in the real world, these models are all mixed together. In terms of what you actually do in any given situation, yes, you're delivering information, but you're also trying to stimulate conversation and so forth. So I said in the title that I would try to think about the future of public engagement and why I think it will remain part of science. It's because for dealing with wicked problems, you always have to have public engagement, which means there will be more dialogue, more recognition, I think, of the complex social dimensions. I heard Fanul use the co-production term earlier, that science and society are put together, are co-produced. We will need more research on what the effects of particular projects are, or what some of the issues are. Again, I could talk for hours about that. And we need more people out there practicing. So I'm really delighted to have been part of your conversations, and I'm curious to see where it goes. Thank you very much.
Wonderful. Thank you so much, Bruce, for that trip down memory lane and taking us through where we see things coming up in the future. I want to shoot the first question and just ask you if you could zoom out even further out and think globally about this question, right? What's your perspective, especially thinking about low resource countries that are grappling with this question of science and society?
So this is a really interesting question. In the last 3 years, there's been the development of a field called inclusive science communication, which is recognizing that there's a lot that we haven't paid attention to. And one of these is the difference between, for example, developing countries where issues of clean water or access to medicine or access to healthcare are really fundamental issues, and where sometimes maybe deficit model, just deliver information and also deliver some infrastructure, might be more important than facilitating public discussion about nanotechnology and artificial intelligence. So there's a sense in which the field, which we've been pushing for public engagement in that two-way dialogue model, maybe we need to be thinking a little bit differently about context and where different contexts matter. We also have to think a lot about just access and marginalized communities. There was a couple of the earlier presentations focused especially on Latina communities and on Spanish. A woman, Ana Maria Porras, who just finished a postdoc here at Cornell, she does Microbe Mondays on Instagram, where she crochets microbes and then talks about them. She and a colleague published an article showing how little science of any kind is published in Spanish, one of the most common languages on our planet. And by restricting things to English, even in developing countries, we're restricting it to elites, because that's typically who's likely to know English. So there's some real need for us to question some of our own assumptions and to be reflective, again, which is why I started out with that land acknowledgement.
We agree. Questions, everyone, please jump in. And raise your hand. I'll pick on you. Yeah, as people think of their question. Oh, Jonathan, there we go. Jonathan, go ahead.
Thanks. I appreciate that. Again, wonderful talk. Thanks for giving some thought, food for thought. One of the things that you mentioned as you're transitioning from 19th to 20th century. Oh, sorry, there goes the dog.
Of course.
Of course. One of the things that you alluded to that would have been, I'd like to hear more about your thoughts on, is that the transition of how education was delivered between the 19th and 20th century, and the purpose of public or even private education for what was the ends to that those means were driving at. The reason why I mention that is because I think one of the reasons, and there's lots, but one of the major reasons, in my opinion, and why we got to where we are and how we regard science as, for the lack of a better word, a slave to economic development, rather than as a means to knowledge and personal fulfillment. One of the reasons, in my opinion, is because we've started teaching science from worksheets for about 100 years. And so now people aren't looking at science as this, wow, this is a great thing and I want to explore. The phrase you used is, what do I need to know about this? And that is the, okay.
Keep talking.
Okay, I was just gonna say that, in my opinion, that is the direct consequence of how we actually teach science, right? And instead of science being exploratory, which we've seen great examples of that today, ultimately, how is it deployed in the K through 12 space? It's in worksheets, right? And if you're lucky, you get experiments,
right?
But then you don't understand why they fit. Anyway, yeah. I want to know your thoughts.
Yeah, so there's been a lot of discussion about this in the science education community, a lot of frustration among the elite science educators about the fact that science education ends up being so much rote worksheet memorization. Lots of attempts to say we need to teach less, not more, because what we need to teach is some overarching principles. And sometimes, and the question is, how did that, you're asking is, how did that happen? So the book I went to go grab is called How Superstition Won and Science Lost. And it was written by a historian, now deceased, named John Burnham at Ohio State, who was tracing public communication of science over a 200-year span, from the first 200 years of the United States. And essentially what he argued was that at the beginning of the 20th century, when those science journalists I talked about became professionalized, when you started having professional science teachers rather than scientists doing the communication, you lost the spirit. You lost an attempt to show the scientific method. And by method, I don't mean an idealized scientific method. I mean the messy, complex, muck about in the data, go down a bunch of dead ends, build arguments, and again, a whole nother talk. But that, and instead, as it got professionalized, because of the needs of teaching the masses, of having standardized ways of reaching many people, it became reduced to standardized tools and texts and exercises, where a lot of the creativity is lost and a lot of the variation is lost. So there have been a variety of attempts. In the 1990s, there was something called the National Science Education Standards, which was an attempt to bring back in some of those principles. After 20 years, the educators realized that they had just fallen into a new set of rigid guidelines. And so now, a few years ago, they developed what's called the Next Generation Science Standards, which again are attempt to say, teach less, focus more on thinking broadly, focus more on the real scientific method, provide some historical and social context. It's too soon to see whether that will really work, but this is a recurring issue that people are trying to address. It's part of the tension that we have between a democracy where we want to make science accessible to everyone, and a reality that science is done by elites, by experts for the most part. And there's no solution. That's a tension. And the issue is, can we make that a creative tension? Can we make that a positive, productive tension that allows us to move forward?
And what I see there is opportunity, I think, for researchers and practitioners to, again, be creative in thinking through how can we bridge that gap, right, in making science more engaged, more participatory, right, in nature. I think citizen science has a wonderful opportunity there to do that.
Yeah,
right?
Citizen science is one of the ways. Part of the excitement about citizen science is people recognizing that it has this opportunity to do that. It's not without its problems. Think about the label citizen science. There are projects, particularly some agricultural and environmental projects, where some of the people contributing as participants are undocumented. What does it mean to be a non-citizen, not only non-citizen, someone excluded from citizenship, to be contributing to citizen science? If you're a citizen scientist, what are you a citizen of exactly? All kinds of, I mean, again, we could go down there are lots of rabbit holes I could go down, but.
One thing I love about it, because our summer program, and for our summer interns, if they're still here, that's what we're pushing them to think creative about these questions, these sort of questions Bruce you just mentioned, and poke, ask, right, inquire. And their projects are actually to develop the questions, not even find the solution, develop the questions.
There are all kinds of wonderful questions to look at.
Absolutely. That's what drives me. I'm so excited to hear you just spill them out. Okay, so I'm just looking at the time here. Bruce, this was wonderful. And this is already on the YouTube. We're gonna create chapters so people can click at appropriate times and watch different talks. There's a lot of information that we have to digest here still. I think we're gonna be looking at this for a while. And all the wonderful links you shared, Bruce, and everyone else, I'm gonna have to absorb a lot more. Take time to do that. With that, I would like to welcome you all to our Central Square, SAIS Central Square. And before you click that link, just hold on 1 second. This is gonna be our open platform where we can continue chatting, network, not only with the speakers, but also with each other. And this is open. If you cannot make it now, that's totally fine. Or you can go there for 5 minutes and leave. That's perfectly fine. We just wanted to create a platform for you to be able to continue having conversations on various topics that were created here today as well. I'll also like you, if I can put this up again, please take a moment to scan this little thingy here, QR code on your phones or wherever you are, especially if you are watching this later, and help us by reviewing, giving us feedback on all the talks you've heard today and just overall feedback. We'd appreciate it because we're going to be planning for the next year's symposium or even mini symposium midway through. So keep an eye out for that. Okay. And just to show you what the SAIS Central Square looks like, this is actually the platform where you will be given an avatar. See here, it's me down here. And this is all the space you can explore, talk to people, have one-on-one conversations, private conversations. You can do way more, play games and so forth. But really the key, when we do this every quarter, where we bring in everybody and people can exchange ideas, and on a rotation base, every 10 minutes you switch. But for today, again, this room will be available for you. There's a password in there that I've already put up for you to use. In fact, there's no space between STEM advocacy, so just write STEM advocacy as the passcode to get inside. And with that, I would like to thank you all for attending. I am so humbled by hearing all your wonderful work, and we're just getting started. Big thanks to Bree for the support and bringing us to this point of this. Really, thank you. Huge thanks to Bree. Claire, if you're out there with the comms, thank you as well. And all our newbies that have joined us, Carol, I know you're in here watching, learning. So hopefully this is useful for you as well. To the residents, please keep engaging. This is what I always say. Engage, engage, engage. Find ways to collaborate and communicate. And finally, August 7th is our next session. We're going to have our interns showcase their work. And those questions that I've mentioned earlier, they're going to be pitching those questions to you all. All right. Fantastic. Have a good weekend, everyone. And join us if you have time at the Central Square. Wonderful. Thank you, everybody. Bye. Let's see. Bree, you can end the live stream there. Okay.